Okay, good morning, everyone. I hope everybody has a great spring break. Today I'm gonna start a new chapter, chapter 4, Forces and Newton's Law of Motion. And this chapter 4 and 5 is gonna be most important, chapters for this entire, semester, okay, especially chapter 5. So chapter 4 is the base of chapter 5, okay? And then here we'll talk about forces and Newton's laws of motion. Okay, first, motion and forces. So what causes motion? So do you need to keep pushing on something or to keep applying a force to keep it going, right? It seems like based on experience, right? So if you slide a book across a table, it slows to a stop, right? But some simple experiment, we can see that objects slow down at different rates, right? Depending on amount of, it depends on its friction, right? So for example, the sled here is moving, but with the friction, right? And then the more friction, the faster it slows, right? So here, smooth slow, right? This is almost, no, very small, friction, and then this is no friction here at all, right? So you see the sled stop almost immediately here, slowly stopping, and then you have the same constant distance, which means the velocity is a constant, right? So the last case, there's no friction, right? So the Newton's first law is very important, called inertia, right? The consider an object that has no forces acting on it. So assuming again there's no forces acting on the object, then if it is at rest, it will be at rest forever, right? But if it is moving with a constant velocity, it will continue to move in a straight line at a constant speed. You see here, you have two conditions, right? The first condition is what? In a straight line, because if there's no force, its direction, motion of direction won't change, right? And then it is also at a constant speed. There will be no magnitude velocity change. So in other words, this is a what? Nothing but constant velocity, right? What it says here, these two terms, it means constant velocity. Why? Again, velocity consists of two parts, right? Magnitude and direction. Why? Because velocity is a vector, right? So in terms of direction, it says a straight line, so no directional change. And at a constant speed, that means there's no magnitude changes. So in other words, if there's no force, it will move at a constant velocity, right? That's a Newton's first law. Again, Newton's first law is if there's no forces acting on the object, if it is at rest, it will remain at rest. If it is moving, it will travel with a constant velocity. And then what is the force? Force is a pull or push, right? Or force, and then the thing is a force act on an object, right? So basically force is from one object to the other object. Okay. And every force has an agent. So that's what I'm saying, right? So this is from one force, one object to the other object. So that is called agent. The first object is called agent, right? And then something that acts, pushes or pull only. Okay. Okay, and then a force is again, a vector. So what does that mean? Force has a magnitude and it's a direction, right? So that's why we sometimes, draw force with this vector sign, right? the size of strength such a force is a magnitude F without the vector sign here, right? So that sometimes we have a contact force that a force is that act on the object by touching it, or sometimes we have a long range force without any physical contact. And then next one here is combining forces. So sometimes if you have an object, there are more than one forces are acting on the object. So for example, F1, F2, F3, three forces, or sometimes even more, are exerted on the object. And then the combined force, in other words, the net force, that is simply the vector sum of all these forces. So the net force is sometimes called resultant force, but basically they are the same. It is not a new force, but this is the sum of all forces. So in other words, net force or resultant force is the sum of all forces acting on the object. So for example, let's assume you have an object here, and then there are two forces acting on it. The first force is acting this way, and the second force is acting this way. So if we simplify this case, this is F1 and this is F2. And then the vector sum, you remember, remind yourself, how to add more than two vectors, right? So basically you move vector 2 right over here, right? So this is a vector 1 plus 2. So this is a F net. So then you will see this object will move along this line, right? But that doesn't mean each force acts, along this direction. The final motion of the box will be determined by F net, not by individual forces. In addition, F net again is not a new force. This is a simply sum of these two forces. Again, this is not a additional new force. It's called again resultant force. Right? And then the net force on the object points in the left. Two of three forces are shown, which are the missing third force. So now, if you have so basically the final motion net force will be F1 plus F2 plus F3, right? And then you can clearly see some of these two forces, F1 plus F2 is along this line, right? So then after you add F3, your net force must be points to the left. So then this is a F1 plus F2. And then later you have to move something like that way so that your net force is going to be to the left, right? So the answer is C, right? And then list of forces, the first forces you will see is a weight, right? So in other words, that's the earth is pulling an object downwards. Its direction is always point to the downwards or to the center of the earth, right? And the spring force, we'll talk about it later, so we don't need to focus on. And tension, we'll use this force over and over, right? So a rope exerts the tension force on the sled. So the tension force, the direction is always along the string. Okay, so that is called the tension force. The direction of the tension force is always in the direction of the string or rope. And then normal force is a force exerted on the object that is pressing against the surface, right, in the direction perpendicular to the surface. So the direction of the normal force is perpendicular to the surface, right? In other words, another name of normal force is a support force, because the normal force is the force exerted by the surface against the object. So in other words, the desk, for example, is a support this textbook over perpendicular to the desk surface. Okay? And then for example, again, this is important example. You see the normal force, one very common mistake is the normal force, students assume normal force is always over. No. Again, the normal force direction is always perpendicular to the surface. So if you have a ramp like that, your normal force is perpendicular to this surface, not always a straight up. And the friction force, you have two different type of friction force, kinetic friction, static friction, but we'll talk about it later. Okay? And the drag, we'll talk about it later. Thrust, electric, magnetic forces, we'll talk about one by one later. Okay? It's just a list of forces. So now, important example, a ball lowers down in incline and off a horizontal ramp. Ignoring air resistance, what force or forces acts on the ball as it moves through the air just after leaving the horizontal ramp? So basically, the ball move along this ramp, and at some point it will leave, and it will be in the air, right? So what is the force? You can guess the motion of the ball. The motion of the ball will be something like this, right? And then what forces are acting on this ball right this moment? Of course, weight is acting downwards, right? So that A is right. And then any horizontal force that maintains the motion? No. You see, chapter 3, what do you see? Horizontal acceleration for this free fall motion. In other words, this is a two-dimensional trajectory motion. A, x is 0. So there is no acceleration, horizontal acceleration. So there's no horizontal forces there, right? So then the answer is A, right? So don't assume because the object is moving to the right, while it is, moving downwards as well, right? It's moving to the right because of its initial condition. But that doesn't mean there's a still force there, right? Acting on the ball in the air. A steel beam hangs from a cable as a crane lifts the beam, right? What force is acting on the beam? So then beam here, right? And then cable is here, right? So then what force is? Weight acting downwards, and then tension is along the string, right? So the answer is B. And then Bob later pushes her sled across the horizontal snow, right? To get it going, right? Then jumped in. After she jumped in, the sled gradually slowed down, right? To help. What force is acting on the sled just after she jumped in? So after she jumped in, what happened here? So this is sled, and it should be here, right? And then it will go there and then slows down, right? So the weight is acting downwards. And the normal force from the ground will be here. And then because it slows down, friction forces, right? So the answer is D, right? And then identifying force is still one of the most important steps you have to know how to, right? So the basic idea here is a typical physics problem describes an object. This is an object that you are interested in, right? Are being pulled or pushed in, various direction based on various forces, right? First, you must identify all forces acting on the object. This first step is very important. You must identify all forces acting on the object, right? Some forces are given while some are, hidden, right? So you have to find out all forces and then make sure to avoid including forces that does not exist, right? So you always have to include the forces that is there, right? And then this text box is important. First, identify the object of interest. So sometimes your question involves more than one object. So make sure you have to identify the object that you are interested in, right? And then draw the picture of a situation. In other words, that is called force diagram. Identify all forces, okay? And then draw a closed curve around the object. This is not necessary, but you can do that. And then locate every point on the boundary of its curve where other object touches the object of interest. This is also to find forces, but that's not necessary. But step number one, make sure you can do this. Okay. And then second step, actually, I would say, even though you have a three steps, I would say this is your first step, identify the object. And the second step is the find the all forces. Number 5 and 6 is actually finding contact force, finding long range force. So I combine these two, and then in other words, this is a find all forces acting on the object that you identify of the, that is the object you are interested in. Just two steps: identify the object and identify all objects, forces acting on the object, right? And then, for example, you have a bungee jumper, and then this case is exactly the same, right? So this human is the weight is straight acting downwards, and then tension is acting up, right? So this is a first step. What is your first step? Identify object. That is this human. And the second step is finding all forces, weight and tension, right? Same. The object you are interested in this human, and the force is what? Tension, and the weight straight down, and normal force up, right? Something like that, right? So what do forces do? Cart is pulled to the right with a constant steady speed. How will its acceleration graph lose? So this is a constant force. So that means your acceleration is a constant as well. So the answer is a C, right? And then finding the mass of an unknown block. So when a rubber band, okay, I think, yeah, a rubber band is stretched to a 1 kilogram block with a constant force. The acceleration of the block is measured to be 3 meters per second. So now we have three things, right? Mass is a constant force, and then acceleration is 3. When a block with the unknown mass is pulled with the same rubber band, right? So the rubber band will apply the same force, right? Using the same force, its acceleration is a 5 meters per second, right? So what is the mass of unknown block? So then now you see the first rate is m over 1 kilogram, right? So the heavier your mass is gonna be, if your mass is heavier, then acceleration is gonna be smaller, right? So then you see the ratio is gonna be 3 to 5. So in order to make this ratio 3 to 5, you need a 0.6 kilogram. So today's lecture is relatively short because this is one of the easiest chapter you will see, because this is the basis of basic of next chapter 5, which is the most important chapter for this course. Okay, so make sure you understand, the today's lecture clearly, and then let me know if you have any question. Thank you. And then your homework is due soon.